going to move on and talk about population growth now. So when we talk about populations, we're talking about the population of a species in a given area. So we generally are not talking in terms of the entire population worldwide, unless we're talking about humans. So with humans, we talk about the worldwide population. Most other populations, we're looking at them in a particular area. And so population growth can go a couple of different ways. This graph that you're looking at here, this shows exponential growth. And in exponential growth, what you'll see is maybe a level line and then it just takes off all of the sudden. So in exponential growth, the birth rate is much, much higher than the death rate. So a lot more births than deaths occurring there. Then we also have another type of growth. This is logistical growth. Okay, so you'll see this kind of steadiness of the line here, and then you will see an increase. And in some populations, it's a very sharp increase. In others, it's a little bit less of a slope. But you'll definitely see this leveling out. So it reaches a level, and then it flattens, okay? And that's how we know that it's a logistical population growth. At this point B, what's happening there is birth rate equals death rate. So at B, births equal deaths. So you have this evenness, okay? Where it's going up, the birth rate is much higher than the death rate, but once it reaches B, the births equal the deaths, and so that line is going to flatten out and just keep steady. And we call this carrying capacity. So at K, what you have is you have carrying capacity. And what that means is that this particular species has reached a point where it's using all of its available resources, and it can't have any more. It can't add to its population because its resources are limited. So something there is limiting the population size. It might be the amount of food that's available. It might be the amount of water that's available. It might be the amount of mates that are available. So something there, and it could even be a combination of all of these things, but something there has made the population reach carrying capacity. That is all that the environment can support. There can't be any more in the area. All right, so competition is pretty much what drives most organisms. There's competition for food, there's competition for mates, and there's competition for shelter. And so competition is really what will cause an organism to pick its niche, or to fill a niche would be a better way to say that. So because of competition, animals cannot just inhabit the entire forest because there's too much competition and too much danger. So what they do is they'll fill a particular niche. They'll fill an area where there's enough food, there's enough shelter, they have access to their mates, and so they'll fill that particular area, and that kind of helps them avoid competition with other species. So here's kind of the effects of competition. This shows that this particular species of warbler, and there's actually 4 species shown here. So we have the Cape May warbler, and it lives in the tops of the trees. The bay-breasted warbler lives in the middle area of the trees, and the myrtle warbler lives more towards the bottom range to the middle. The black-throated green warbler, it lives in this middle area as well. and the Blackburnian warbler lives towards the top, okay? So because they've each filled the different niches, they coexist together and they're not competing as much. Like the Cape May warbler doesn't have to compete with the myrtle warbler. They're separate from each other. These guys are using a different food source. They're using a different type of shelter, so they're not competing with this warbler. And so that reduces the amount of competition, because they may have to compete a little bit with this bay-breasted warbler. See where their niche kind of runs together here? And then same with this one. They may have to compete a little bit with this guy because they are using the same resources. But because they're filling the niche, they don't have to compete with all of the birds in the forest. We have some symbiotic interactions between organisms. Symbiosis just means living together. And so we see 3 different basic interactions. We have parasitism. Well, parasites, they live on the host, and a lot of times they kill the host. They're feeding off of the host, and so the host will become sick or even die. But the parasite generally lives inside of the host, or like in the case of fleas and ticks, it might live on the host, like in the fur. And then there's commensalism. Commensalism is a situation where the one animal gets a benefit, but the other animal doesn't really care. It doesn't get a benefit, it's not harmed by the interaction, so it really has no effect on it. And we'll see this with birds that ride cattle. So a lot of times we'll see these birds that are on the cattle, and some people will think that this is mutualism because they'll say, well, it's eating the bugs off of the cattle and that's got to be good. Well, what it's actually doing is the cattle's kicking up bugs from the grass down here, and so the bird is eating the bugs that are kicked up as the cattle walk through this tall grass. And the cattle, they don't really care. It doesn't really matter to them. And one of the reasons why we say it's commensalism, where one benefits and the other doesn't care, isn't harmed, or isn't helped by the interaction, is because the cattle, it doesn't matter to the cattle what bird is on its back. So it might be an egret or it might be a different type of bird. Doesn't really matter to the cattle. And then we have mutualism. And mutualism is where both species have a benefit. And so we see this with clownfish that live in anemones. An interesting thing about the clownfish is that they go into the anemone quite often, and the anemone basically gets to where it stops stinging them. And then even if it does sting them, the clownfish is basically immune to it. But the clownfish is protected by living inside the anemone, and the anemone gets some benefit from the clownfish because the clownfish is moving the water through the anemone, and that brings food in. Okay, so all of these ecological factors that we've been talking about are basically, they're basically a way for ecosystems to be in equilibrium. And equilibrium just means balance. So equilibrium is important to an ecosystem. There needs to be a balance so that everything is healthy, so that you have healthy plants, healthy animals, you have a healthy water supply, a good air supply that's not polluted. So ecosystems really do strive for this equilibrium, for this balance. But then things can get out of balance sometimes, and a lot of times that balance is affected by humans. So ecosystems often will become unbalanced because of human interaction. So a lot of times we're developing in these areas, and that causes problems for an ecosystem. We sometimes will pollute the water or pollute the air, or we will overhunt or overfish an area. And so all of those things can put an ecosystem out of balance. Another thing that puts ecosystems out of balance is environmental effects that are natural, like a lightning strike that would cause a fire, or an earthquake, things like that can happen. But soon after these events, ecosystems really do work towards an equilibrium. They'll work towards getting back to a balance. And in the next section, we're going to talk about the human impact on the environment.